So, hello, my name is Simon. I'm a cybersecurity engineer, an active cybersecurity practitioner, and I do a lot of research when it comes to cybersecurity and the related topics. So today I want us to look at developer boards. So, and with us today I have 4 boards. I have this one, I have this one, I have this one, then lastly I have this one, and I'll be going through them and I'll be explaining the applications and their relation when it comes to cybersecurity. So with me here, this smallest one is called a PicoPi, and a PicoPi is a small board and it's made by the Raspberry, and it has a storage of 2 MBs and a RAM of 264 KBs. It's an SRAM. It has many other specs, but we'll just look at the key specs. And it takes a power supply of 1.8 to 5.5 volts, and it connects via a port. I will go back to that. Yes, and the other board, this is the Raspberry Pi 4. It's the model B, and this is actually this is considered as an SMB, and it's not a microcontroller or a microprocessor. This is an SMB. An SMB is a single board computer. It means you can be able to install here your Windows probably, but I've seen it run with Kali Linux and other firmwares, the Meshtastic, which I'll talk about it when it comes to cybersecurity. It's quite essential. Yes, and I'll go to the other board. So this is the ESP devwloper, and this is the board I've been using. It has a flash memory of 4 MB up to 16 MB, depends on the module. But for this one, it's called devwloper, so it has 4 MB. It has an SRAM of 520 KB, and it goes up to plus an 8 Mbps RAM. It's optional. It supports Wi-Fi connectivity, Bluetooth connectivity, and for Wi-Fi is the 802.1. and for Bluetooth is the version 4.2 classic plus BLE. BLE is the Bluetooth low energy, and it has up to 34 programs. Those are the pins. Power supply of 3 to 3.3 voltage, but also has a 5 voltage pin. We'll talk about that. And with me here, this is the Arduino Mega, and with the Arduino Mega it has an SRAM of 8 KBs, a flash memory of 256 kilobytes, it's in KBs, and it has an EEPROM, that's the ROM, of 4 KB. It's supposed to up to 54 digital pins, and uses USB-B for programming. It has a cable. This one looks like the printer cable, but this side is the USB-B. A power supply of 7 to 12 voltage, and that's via the barrel jack or the VIN, and you can program it with the Arduino IDE, same to the ESP32. So then with me here are 3 modules. So this module is a screen. It's called a 0.96 OLED screen, and it's specifically for the ESP32. The other component is this called a 2.4 TFT screen. It's a touch resistive screen, supports touch screen, and it's multicolored. It can both operate from the Arduino Mega, and in Arduino Mega it's called plug and play. It means I can be able to just plug it by considering the pins and be able to plug it directly here, something which I want us to do. So I'll look at the pins and how the pins are, the labeling of the pins, and this is how it works. This is called the plug and play. You don't need a breadboard. This is a breadboard. It's used for connectivity. You really don't need a breadboard. And after the plug and play, I'll connect it to my power supply, and after connecting it to my power supply, I've already loaded it with a program. You see it's on, and the program in it is loading. Just give it a minute. This is the reset button. It just extends from here. You can see it already has a program that is running. And the third component is called an NRF module. So this is a wireless connectivity extender. It extends both the Bluetooth and Bluetooth and Wi-Fi signals up to 10 meters, and if it's a radius of 10 meters to be specific. And so we come to the applications. So the ESP32 is a very powerful microcontroller, and you've seen the likes of Ryan Montgomery is the one among the best. He's a great hacker. He used to be an ethical hacker, but later reformed and became an ethical hacker, and he does a lot of good things on the internet. This, and I've already done it, can be programmed and it can do very powerful tasks. So the program I had is a Bluetooth/Wi-Fi jamming, and it could create something called a DDoS. So DDoS is distributed denial of service, and DDoS works this way. Let's say you are a person who delivers 50 orders a day, and I give you do deliver 50 orders from different people a day, and one day you come to me and I give you 100 orders. It means the rest of the 50 orders won't count because I've already given you 100, and already the 100 is overwhelming. It means nobody will be able to give you orders, and you will not be able to complete the 100 orders for a day. That's how the DDoS works. It overwhelms whatever you are attacking by many requests, so that no other person could be able to request. So it disables them from connecting, and an instance of a Wi-Fi, they won't be able to connect to that Wi-Fi network. And I come to this is a Pi 4. So Pi 4 can run a full operating system. It has a memory card slot. So what you can do is you load your operating system on a memory card. It has a Pi flasher. You just flash the operating system onto a memory card, then you insert here. These are HDMI ports. It supports HDMI. These are an Ethernet port, and these are USB ports. There are 4 USB ports, 2 HDMI ports, and these are Type-C power. It's a Type-C power port. I presume it has an LED, and when I connect to the power, you can see it's powered on. So it's on, it's functional. This Pi 4 board is functional, but it has its own screen, and it has a place where you can connect the camera. So there's a firmware called Meshtastic. So what about the Meshtastic? Meshtastic is a firmware that allows off-grid communications. Now off-grid communications are most of us are subscribed to either Safaricom, Airtel, or any other network providers. So our communications are on grid. It means whichever time I'm coming up to pick a call, I must be connected to a booster, and I'm on grid. I'm using a booster, and with a process called triangulation, we can estimate your location. Consider by you just connecting to 3 boosters around. So the Meshtastic firmware, you load the Meshtastic firmware here, and you give it a networking module that enables it to project, let's say 30 kilometers. The one I've seen, it projected up to 5 kilometers. So, and then you can create a group of them. Let's say after 5 kilometers, you put another. So anytime you are making communication, you're directly using this Pi chip, and your communication cannot be monitored since it's off grid. You are not using any SIM card, you are not paying for credit card, you are not paying for airtime, you are just using it directly. And Meshtastic is Linux native platform. It's works hand in hand with Linux, or it's Linux based. And considering this PicoPi, several projects have been created by this. There's a developer I saw creating he created a smartwatch, a simulation of a smartwatch using this and a certain screen. It's a rounded screen. Probably I'll have time to, maybe by chance I'll get across it and I'll be able to display. And this is called a breadboard. This is an extender board. It allows me to plug several components without doing a lot of wirings or doing a lot of connections. And when it comes to components like this is called this is a capacitor. For this component to work, we needed a capacitor. So since maybe let's assume I'm having 5 capacitors, it will be easier for me to place them on the breadboard. but then there's a choice of creating a custom PCB and being able to format all your data there. And when we come to this, this is the Arduino. We have several Arduinos. We have the Arduino Uno R3, we have this Arduino Mega, and several Arduino components. Yeah, they are quite useful. And I saw a Kenyan had made a Kenyan, I'll be able to tag him. You see the project. He was able to make a mouse, a fully functional mouse that works on a Windows machine using this module and several other controllers or several other added modules. These are added additional modules. The board comes this way. He was able to make a mouse, and you can make several things, but considering its storage and its RAM, it means the processing is low. So running this screen, TFT touch screen on this, you can be able to just display images, and it means since the processing power of this is low, very low, you can only be able to project images, the JPEG and bitmap images. So that's all about this. Its power is low, but it can do several things. People have been creating temperature monitors, people have been creating location monitors. There are so many projects, and they are being made by Kenyans. One of them is Mr. Arduino. He creates great projects, but our main focus when it comes to these microcontrollers and this one SMB, we are really focusing on the cybersecurity aspect of it. So from this, I've created something security. Yeah, I've created a security Wi-Fi jamming and Bluetooth, and this can be both used ethically and unethically, but I'll put the ethical way. Assuming you're on an apartment or you're on a place and people are playing loud music and you want to sleep, maybe they are not, you've tried to ask them to turn off their music or to lower it, and they are not cooperating, and just use this one to jam their Bluetooth. Though it's quite unethical, but sometimes it's healthy, considering maybe you have a meeting or you're doing something online that requires you not to be in a noisy area and you have no other place to go. Probably it will be an option. And their prices ranges. So this one ranges from 1500 to 2000, and this one costs around 12 to 15,000. I'm not sure about the price to this one. The components, this screen costs, this one costs 2,000 shillings, 2,500. The component, this one TFT touch screen costs it's 1,800. This module is 500 shillings, Kenyan shillings, and this small screen is 800 shillings. So they're quite expensive, but when it comes to cyber security, the microcontrollers and this one SMB are helpful and can be used to do so many projects. And that's for today's topic. I'm preparing something on networking, so we'll be able to continue with our daily projects. Thank you.